All right. So, hello everyone, and then good to see you all again. Um, so basically, today's tutorial is about um strength of materials one. Okay, and then basically, I want to solve some couple of problems with you to prepare you for exams. So kindly share the link to your friends. Strength of materials one. Okay, and then
All right.
basically,
So,
I want to solve some couple of problems with you.
all right.
So if you have joined, okay, can we start, please? Can we start? So in today's tutorial, I want us to look at introduction, or let's review centroids and then area moment of inertia. So area moment of inertia, because this will help you um in your bending stress. If you don't understand the centroid and the area moment of inertia, you cannot do um the bending stress. Okay, and then tomorrow we will do uh the bending moment and the shear force diagram, and then hopefully we can also look at the Mohr circle. Okay, all right. So let's begin. All right. So I just want to take a question and I will use the question to teach you. Okay. So first of all, let's look at a centroid question. So give me some few minutes, and then I want to put a question on centroid there. Okay. So first of all, before we look at the centroid question, I want to post something which you have to know. Um okay. Okay. So I want to show you this image here. Um can you all see my screen, please? Can you all see my screen? Okay. So now basically whatever you are going to do in centroid will, fall in this kind of questions. Okay. So Okay, thank you. All right. So you can see that what they are centroid, but I want you to pay attention to um four things. So first of all, if you look at um sorry. So first of all, if you look at the rectangular area, so this is number one, and then the semicircular area, that is number two, and then the quadrant. So the quadrant is number three. So look at these areas, and then these are some of the formulas that you can use in solving a problem under centroid. Okay. All right. So maybe let's take one question which will help you to understand the centroid very well. Can you hear me? Hello, please, can you hear me? Hello, can you hear me? Can you hear me? Okay, thank
Hello,
you.
please, can you hear me?
All right. Okay. So hello, can you hear me? I want us to look at this question.
Can you hear me?
Okay, thank
Hello,
you.
please, can you hear me?
All right.
Okay.
So
So, hello, can you hear me?
I want us to look at this question. Okay.
Can you hear me?
All right. So let's say that I have a question like this, and I have been asked to find the centroid. Okay. Let's say you have a question like this, and you have been asked to find the centroid. How can you be able to find the centroid of a figure like this? Okay. So without wasting much time, let's go straight forward and then solve it. So if you have a question like this, the first thing you have to do is to divide these areas into regular areas. Okay. You should divide these areas into regular areas. And then once you're able to divide these figures into regular areas, then you can now solve it. Okay. All right. So first of all, okay. So first of all, you have to divide the area. You have to divide the area into basic areas. So how many areas do you see? Please type it. How many areas do you see in the question? Or how many regular areas do you see in the question? How many areas do you see in the question? Okay. So now you can see that there is a rectangle. So there is a rectangle, and then we have a triangle, and then we have a semicircle. All right. But the rectangles are two actually. So in all, we have 4 areas. So the areas are 4. All right. So the areas are 4. And then we have a semicircle. Okay. So actually the areas are 4. All right. But the rectangles are 2 actually. Okay. So in all, we have so then 4 areas. So the areas are 4. Okay. All right. So then let's start. Are 4. And then we have a semicircle. So the first thing that you have to do is to identify the origin. Okay. Identify the origin. So the origin is this point here. O. Okay. That is the origin. Then you have the x direction in this sense. So that is your x direction or your x axis. Then you have your y direction in this sense. Okay. All right. So now you have your x axis, then you have your y axis, right? So first of all, you have to identify the areas. So you see that there is one area here. So there is a rectangle, there is a semicircle. So this is rectangle 1, and this is rectangle 2. The semicircle is area 3, and the triangle is area 4. Maybe let's do it in that sense. So we are going to start with the x bar and then the y bar. Okay. Now when we say x bar, so when we say x bar, or let's say find the centroid. Find the centroid in terms of the x bar and then the y bar. Okay. All right. So x bar, y bar. First of all, let's start with the rectangle. So let's find the x bar for the rectangle. Now, when we say x bar means that starts from the origin and move to halfway of the area. Okay. So start from the origin and move to halfway of the area. In other words, if I ask you to move until you get to halfway, how are you going to do that? So let's assume that the center of this rectangle is somewhere here. Okay. If I want to walk towards the center, first of all, I will have to walk some distance along the x, and then I will move up some distance along the y. But for a rectangle, halfway is very simple. Just divide the x distance by 2. You realize that the whole of this distance is what? 120. So it means that I will have to walk all the way halfway, and half of 120 is what? 60, right? So it means that for the rectangle, halfway here is going to be 60, and then going up in that sense will also be what? 60. That's all. So in effect, the x bar is 60 and the y bar is 60. In other words, to get to the center of the rectangle, you just have to walk from the origin 60 millimeters, and then you go up 60 millimeters, and that's all. Okay. So in simple terms, the x bar is going to be 60 millimeters for the rectangle, or 120 divided by 2, which is 60 millimeters. And then the oh, I'm sorry. Yeah, I think it's correct. Okay. Yeah. Yeah, it's sorry. It's actually not exactly half. If you look at the y, so the x is 60 but the y is not 60. Now if you look at the shape very well, the distance going up here is not exactly 60. So please take notice of this. You realize that if you move from the origin towards the y, who can tell us the distance? Who can tell us the distance? Now if you look at the shape very well, because from here to here is 20, it's not exactly 60, and then this one is 40. So please take notice of this. You realize that, okay, and then this one too is what? From the origin towards 40. The y, who can tell us the distance? Who can tell us the distance? Now if you look at the shape very well, because from here to here is 20. So now if I add it up, and then this one is 40. So please take notice of this. Plus 40 plus 20. Okay. And then this one too is what? So 40 plus 20 will be what? 100. Which means that the whole of this distance here, which is the same as the whole of this rectangle here, is 100. Thank you. So now it is 100. So what will be half of 100? In other words, if I ask you to walk halfway of the figure, so what will be half of 100? 50. Thank you. So the answer is not 60, it is half of 100, which is 50. So when we say x bar and the y bar, it simply means start from the origin and walk to the center. That's all. I hope it's clear. So the distance is going to be 50 millimeters. That's all. Okay. Any question up to this point? All right. So now let's move to find the area. Let's find the area of this rectangle. So the area of the rectangle is what? Is straightforward, right? Length times breadth. So it's going to be what? 120 multiplied by 100. So 120 millimeters multiplied by what? 100 millimeters. So 100 multiplied by 120, and that gives us 12,000 actually. So we are going to get 12,000 millimeters squared. Okay. All right. So essentially we have done x bar, y bar, and the area for the rectangle. So let's move to the other area. Okay, let's move to the other area. Okay, so now if you look at the other area, let's look at the second rectangle. Now if you look at the second rectangle, what do you see? If you look at the second rectangle, so I'm talking about this small rectangle. So I can clean the one for the bigger one. Now I want someone to tell me, so this rectangle has a distance from here to here as what? 20. So let's say exactly half of 20 will be what? 10. So who can tell us the distance from here to here? If you add everything, okay, so we are moving along the S direction from the origin. So it's going to be this. We are moving all this way to halfway. Now, half of 20 is 10. So already this distance here is 10 millimeters. Okay. So from here all the way here. Now who can tell us the distance? So from here to here is 30. And don't forget that this one here, so don't forget that this one here is actually like the radius is 30, which means, okay, someone said 120. Let's see. So which means if this is 30 as the radius, then the diameter will be what? 60, right? Okay. So 30, okay, let's see. So 30 plus 60 plus 20 plus 10. What is that? Okay. So 30 plus 60 plus 20, and then plus 10. So it is actually 120. So those who said 120, you are correct. Those who said 120, you are correct. So for the small rectangle, the X bar is 120 millimeters. Okay. And then, so who can help us with the Y bar? Who can help us with the Y bar? So with the Y bar, look at the center of this small rectangle here. The distance from here to here is 20. And then half of 40 is going to be 20, right? So 20 plus 20. All right. So what is the, okay, please, I have not done anything yet. Right now we are just doing the area and the S bar and the Y bar. Okay. So I want to take my time and do it. So we are not doing anything right now. We are just going to do area, S bar and Y bar. After getting all of the values, then we look at you know we look at the calculations. Okay, so someone said 40. Yes, you are right. So halfway of 40 is 20. So it means 20 plus 20 is 40. So Y bar is going to be 40. How about the area? Now let me teach you something. You realize that the area is going to be so this distance here is 20, and then the height here is 40. So 20 times 40. So it's going to be 20 times 40. And that gives us what? 800 millimeters squared. But watch this, everyone. Pay attention, everyone. Now, what happens is that the height here is 40. Mostly, so whenever you are looking at 40, centroid, and then you have a hole inside, this hole 40, is thought of as what? It's thought of as a negative area. So bear in mind, whenever you have a hole, it is always a negative area. Now what happens is that the height here is 40. So all the time, pay attention, please. Centroid, and then you have. So always pay attention. All the time, whenever you have an area which is like this, then it's actually a negative area. So all what we are going to do is to negate it. That's all. So the area will become negative. Why? Because there is a hole. That's all. All the time, whenever you have an area which is like this, then it's actually a negative area. So all what we are going to do is to negate it. That's all. Okay. Now, so the area will become negative. Now, why? Let's look because at there is a hole. That's all. Semicircle. So let's look at the semicircle. The time, whenever you have an area which is like this, then it's actually a negative area. So all what we are going to do is to negate it. That's all. Okay. Now, so the area will become negative. Now, why? Let's look because at there is a hole. That's all. Semicircle. So let's look at the semicircle. The time, whenever you have an area which is like this, so let's look at the semicircle. So with the semicircle, this is what you have to do. So let's pay attention here, please. So what will be the distance along the x towards the center? So this is the center. Okay, 40 millimeters. Thank you. All right. So with a semicircle, the distance from here to the x, who can tell us this distance? The distance from here to here is 30. And then the radius, don't forget that the distance from here to here is the radius, which is also 30. So what is the x bar for the semicircle? What do you think is the S bar for the semicircle? All right. What is the x bar for the semicircle? 60. Thank you. It's 60. So x bar is going to be 60 millimeters. Right? How about the y bar? So please, everybody pay attention. This is where we have to use the formulas. Okay. So, all right. Yes, the area is 800, but we will have to negate it. All right? Okay. Okay. So it's 60, yes. But wait. Before you can look at the Y bar, please, everybody pay attention here. This is very confusing. Um, how do I put it? It creates a lot of confusion among students. So please pay attention. It is not 30. So let me give you the solution. Whenever you have a semicircle, okay, whenever you have a semicircle, the Y bar is actually a certain distance, okay, and that distance is somewhere here given by, so for um a semicircle, the Y bar is 4r over 3 pi. So this is how we calculate it. There is a formula here. I want to show you. There is a formula here. Everybody, can you see what is here? Okay. You will realize that for a semicircle, all the time the centroid is at a certain distance given by 4r over 3 pi. So to get the actual answer, the Y bar will be 4 times r, which is the radius, which is 30, divided by 3 pi. Now if you do 4r over 3 pi, you are going to get what? So 4 times 30 divided by 3 times pi. And that will give you 12.73. So the Y bar is 12.73 millimeters. Any question up to this point, please? I know that this will create a lot of confusion. I know that this will create a lot of confusion, but please bear with me. Any question up to this point? Okay. So this is only special to a semicircle, okay? And then a quadrant sometimes. So 4r over 3 pi. Now let's calculate the area of the semicircle. Because it is a semicircle, or in other words, because it is a um half circle, the area is going to be half times pi r squared, okay? So half times 30, so half times pi times 30 squared, okay? And what will be that? So we have half multiplied by pi multiplied by 30 squared. That will be 1413.72. 1413.72 millimeters. But please, let's come back to the area. So for the semicircle, what do you think? Should we negate the area or not? For the semicircle, should we negate the area or not? What do you think? 1413.72 millimeters. But please, let's come back to the area. So for the semicircle, what do you think? Should we negate the area or not? For the semicircle, should we negate the area or not? What do you think? 1413.72 millimeters. But please, let's come back to the area. So for the semicircle, what do you think? Should we negate the area or not? Okay. So you realize that um because of the fact that we have this one here, clearly we have to negate it, right? Who does not agree? Because the area is a hole. You can see that it has been cut away. All right. You can see that it has been cut away. So it's going to be negative. Okay. All right. Um, so now what else do we have to do? We have gotten the area. Okay, so left with the triangle and then we are done. So let's look at the triangle and then we'll be done. So this is the triangle anyway. So let's look at the um triangle. Okay. So if you look at the triangle, there is another formula which we have to use. And please, I want you to also pay attention again. I want you to pay attention again with respect to the area of the triangle. Please pay attention, everybody. All right. So with regards to the triangle, there is a formula which we have to use. So let's go back and look at the triangle. See this, everyone? Can you see this? There is a certain formula here. There is a certain formula here which talks about h out of 3. Okay. So essentially, if you have um a triangular area, then the centroid is always. All right. So all what we are saying is that whenever you have a triangle, whenever you have a triangle, the triangle will have a height here. So if that height is called h, okay, so if that height of the triangle is called h, then what do you have to do? Okay, if that height of the triangle is called h, what do you have to do? Basically, what we have to just do is that the centroid of the triangle will always be 1/3 of the height. That's all. So it's going to be 1/3 of the height. So let's come back here. Now, pay attention here, guys. First of all, let's look at the x bar. So looking at the x bar, what do you think will be the x bar? Now, this one will be very challenging. To be very, very, very challenging to get the x bar. Let me help you with this one. So we are about to find the x bar. So the distance, uh, okay, let me do it this way. I want to take my time and do it so that you get it. Okay. All right. Okay. The distance is going to be, first of all, the whole of this distance here, which comes here. Already we know that that's what? Already we know that that is 120. All right. Already we know that this distance here is 120. Okay. So now knowing that that distance is 120, then the only thing that we have to do is 120. Okay. So the only thing that we have to do is that we will have to find that h over 3. So let me come back here. So I was saying that, okay, you said 120, 140. Wait. So now there is a special rule which is only for a triangle. Okay, there is a special rule which is only for a triangle. Whenever you have a triangle, what happens is that the centroid will always be at a distance 1/3 of the height. Okay, the centroid will always be at a distance 1/3 of the height. Okay, so if I come back to the figure, then I ask myself, okay, so okay, let's find it together. So for the triangle, the x bar is going to be um so let's find this one first. Already we know that we have 120. Then, okay, I want to take my time and do it. So first of all, let's do the y bar. Let's do the y bar for the triangle. If you look at this whole distance here, 40 plus 40 plus 20 will give you 100, right? 100. Okay. So if you want to get the y bar, you divide by 3. Okay. So the y bar will be what? 100 divided by 3. So that's the y bar. So let's say that the y bar is at a certain distance somewhere. Okay. So the y bar is actually going to be 100 divided by 3. 100 divided by 3. Which is what? 33.3. So that is the y bar actually. So the y bar is 100 divided by 3, which is 33.33. But then the let's look at the x bar. So the x bar is also going to be the same thing, but we will have to first of all um okay. So 120 plus 1/3 of, so 120, and then we will also have to calculate that distance here. Okay, don't forget that in fact it is actually at halfway. So here is 10, here is also 10. So the actual distance is going to be um 10 over here plus 50 actually. Let me do it this way. The distance here is 10. Okay, sorry, I want to take my time and do it. This distance here is 10, and then this is 50. So 10 plus 50 will be 60. But what is 1/3 of 60? So the 60 is the fact that okay, I think I have to clean this. So what we are trying to say is that this line here will divide um the rectangle into 2. So we are saying that this line will divide the rectangle into 2. All right. So from here to here is like 10. And then from here to here is 50. So 10 plus 50, 10 plus 50 is what? 60. So what is 1/3 of 60? 1/3 of 60 will be what? 20. So in other words, the entire distance is going to 120 plus 1/3 of 60, which is what? So the S bar will be 140 actually. How about the area? So the area of this is going to be what? the entire distance is going to 120 plus 1/3 of 60, which is what? So what is the area going to be? So essentially, the area is going to be positive, which is what? Half times base times height. Now the base is what? So the base is actually 60 and the height is 100. So 60 multiplied by 100, and that will give us um so half times 60 multiplied by 100. So that's like 3000 millimeters squared. Okay. So that's like what? 3000. So right now we have everything. So what we will do is that we will create a table. So this is actually from a textbook. So this question is from a textbook, and then this is what we are going to do. First of all, create a table. Okay. First of all, create a table where you will have the areas. You have the x bar, you have the y bar. Then you multiply x bar by the area. You multiply y bar by the area. Okay. So put everything in a table form. Then you add all the areas. You add all the S bar areas. So S bar A, Y bar A. After that, if you want the X bar, you are going to do summation A X bar divided by summation A. And if you want the Y bar, summation A Y bar divided by summation A. Okay. So I have solved several questions on centroid on this channel. I will leave the link below so that you can also go and watch about centroid. So any question up to this point? We are done with the centroids. Any question up to this point, please? A y bar divided by summation A. Okay. So I have solved several questions on centroid on this channel. I will leave the link below so that you can also go and watch about centroid. So any question up to this point? We are done with the centroids. Any question up to this point, please? Okay. So I have solved several questions on. Do you have centroid questions, please? Do you have any question up to this point? Any questions up to this point? I want to solve a question on the parallel axis theorem and the moment of area with you. Okay. So let's look at moment of area. So the first moment of area will give you the centroid. And then the second moment of area will give you the moment of inertia, or what we call the area moment of inertia. Um, let's also take an example question from there. Okay. Okay, let's say you have a question like this, and then you have been asked to solve and get the ixx and then the iyy. So how can you solve this problem? You have been asked to find the iss and the iyy. Okay, so it's simple. Okay, it's simple. So I'm going to teach you what we call the parallel axis theorem. I'm going to teach you what we call the parallel axis theorem, and then how you can use it to solve questions like this. Okay, so let's solve this question. So um let's say you have been asked to calculate iss and then iyy of this question, you know. So the first thing that you have to look at is that we have what we call the reference axis and then the centroidal axis. So number one, we have the reference axis and then the centroidal axis. So when we say the centroidal axis is actually the axis which is shown on the question. Okay. So for instance, if you look at this question, the centroidal axis is that axis which is actually, I mean, um, that axis which is, passing through this body, just as you have it here. For instance, you can see that there is a certain x here. So this is what we call the reference x axis. Okay. And the y axis which you see here is what we call the reference um y axis. Okay. But one thing that you have to take notice of is that, you know each of the areas also have um x and then y, which are actually in the centroid. Okay. So if you have been asked to find the um second moment of area about this figure, what you have to do is that first of all, okay, so this is what we are going to do. We are going to first of all find what we call the parallel axis theorem. Parallel axis theorem. Now, what does it mean? So the parallel axis theorem simply means that whenever you have an axis and then you have another axis which is parallel to it, then there is a certain distance between the two axes. So let's look at the flange or area 1. We can draw an x axis to pass through like this. Okay. We can draw an x axis to pass through this area. Okay. And then, okay, maybe let me use a different color so that you get what I'm trying to say. So let's say that the x axis over here is having this centroidal x axis which is passing through the centroid. Okay. And then this area 2 is also having another centroidal axis which is passing through the centroid. Okay, so there is a reference x-axis, but then you can see that there is also so there is a reference x-axis here. This is the reference x-axis. So now the question is, what is the distance between the reference x-axis and then the main x-axis, the centroidal x-axis and then the reference x-axis? So in other words, what is the distance from here all the way here? And then also, what is the distance from here all the way to this axis? That's all. Okay. All right. So basically what it means is that with this one you have to use the basic concept you have learned in centroid. So we are coming to use the basic concept we know already from centroid. All right, the normal centroid that we know, which we just did. So first of all, we are going to find the centroid of the whole figure. Okay, we are coming to find the centroid of the whole figure first. Okay, so we know that x bar. So we know that x bar is going to be summation ai x bar I, all divided by summation ai. Okay. Now let's come back to the figure. So let's come back to the figure. What do you see here? You realize that to find this one, it simply means okay, and then let's also look at the y bar, summation ai s bar I, sorry, y bar I divided by summation ai. So now let's look at something here. We know that the first moment of area about the x is a y bar, and then the first moment of area about the y is what? A x bar, right? Okay, so let me keep these two somewhere. I'll come back. So guys, let's do this together. A1 y bar 1 plus A2 y bar 2. Okay, divided by y bar 1 plus y bar 2. So who can tell us the reason why we will not use x bar? This is because if you look at the diagram carefully, you can see that the y bar or the y axis divides the area exactly into two. So since the y axis divides the area exactly into two, then the x is actually 0, or the x bar of this figure is actually 0. Let me say it again. Because the reference x axis and the y axis, if you look at the y, you see that the y axis divides the area exactly into two. So therefore it means that it does not have any distance along the x as the center. So already x bar is 0. So all what we have to do is to calculate y bar. Okay. All right. So y bar is going to be, what is area 1? So area 1 is what? 1 multiplied by 10. 1 multiplied by 10. Then you multiply by y bar 1. Now you understand y bar, isn't it? Okay. So let's say that, so now let's say that you have the origin O. So the origin is here at this point. Okay. So if we walk halfway to the center, who can tell us the answer? You are walking from the origin O here until you get to um halfway of the rectangle, actually. Yeah. So I think there's a mistake here. This is 7 and this is 8. But you realize that here is actually supposed to be 8. And then here is rather supposed to be 7. Okay. So who can tell us the distance along the Y for area 1? The distance from here to here is 7. And then this small distance here is 0.5. So then it's simple, right? So 7 plus 0.5. So that's going to give us 7.5. Then we add it to the second area, which will be what? 1, 7.5. Yes, thank you. So 1 centimeters or 1 centimeter multiplied by 7. So 1 times 7, and then um multiplied by y bar 2. So who can tell us um if this is 7, what will be the y bar of this the second area? What will be the y bar? So 7 divided by 2, right? So then it's going to be 3.5, isn't it? Then I will divide here by 7.5 plus 3.5. Are you okay? So y bar for the entire figure is going to be 10 multiplied by 7.5 plus 7 multiplied by 3.5 divided by 7.5 plus 3.5. So what are we getting? Sorry, I think there's a mistake here. It's supposed to be, sorry, summation. So it's supposed to be area 1 plus area 2. So it's actually the area. So 10 plus 7. There's a mistake with the calculation. It's actually summation of the areas, not the y bar 1 and y bar 2. So the actual answer is 5.85. So 5.85 centimeters. That is the y bar. So if you come to the question here, now you have the 5.85 here. Okay. So now we have the 5.85 here. So the actual answer is 5.85. They have done it already here, but I wanted to calculate it with you. So essentially what this means is that we have find the orientation of the x-axis. Okay. In other words, we have been able to locate the y bar of the whole figure. So now we are coming to take the moment of area about that axis. So let me summarize this. Please listen to this carefully. Let me summarize this. Whenever you are given a question on moment of area to solve, the first thing that you have to look at is which axis are you taking the moment of area about. Okay. If you have an axis which is already defined and they tell you that find the moment of area about that axis, you can go ahead and do it. But for a typical question like this, where you've been asked to find the moment of area, first of all, you have to find the moment of area about the centroidal axis first. I'm sorry, about the reference axis. In other words, can you find the entire reference for the whole figure by using your normal centroid that you have? Then you now come and do the question. So we are about to start the question actually. So let's calculate ISS and then IYY, and then we go. So to calculate ISS and then IYY, let's start with ISS. So for a rectangular cross section, there is a formula which we write as BH cube divided by 12, or BD cube divided by 12. Now, for this BD cube divided by 12, this is what we are trying to say. So let's say you have a figure like this. This side is going to be, this side is B, and then this side here is D. All right. So when we say BD cube over 12, all what we are trying to say is that over here, so this multiplied by D cubed and divided by 12. Okay. So let's do it straightforward. Okay. So let me explain it with the formula. So ISX is actually IX about the centroid plus area times D squared. Okay. So IX about the the total ISS is IX about the centroid plus area. So this D squared is coming from the parallel axis theorem. Okay. So this BH cube over 12 is actually the centroidal moment of inertia. So this BH cube over 12 is the centroidal moment of inertia. Okay. So for a rectangle, it is given by BH cube over 12. Coming back to the question, the base for area 1 is 10. So it will be 10 times 1, which is the height or the depth, cube divided by 12. Then plus the area, which is 10 times 1. Then you multiply by d squared. So when we say the d is actually the distance, okay? So d is like the distance. All right? Okay. So what do you think? So who can help us with the distance? So this is the reference axis. This is the reference axis. And then this is the centroidal x-axis of the first area. So this is the centroidal x-axis of the first area. Who can tell us the distance between this axis and this axis? All right. So you can see that it's going to be very much simple, right? Okay. Okay. So let's see. Let's see. The whole of this distance. So the whole of this distance here is 7. Right? This is 7. From here all the way here is 7. But we just saw that this distance from here to here is 5.85. Okay? This distance is 5.85. So who can tell us this distance here? Okay. Yeah, someone said 1.65. You are right. So 1.65. But how did you get the 1.65? So simple. It's going to be 7 minus 5.85. Okay. Now, if you do 7 minus 5.85, that will give you this distance here. And then you add 0.5 to it. So plus 0.5. That's all. So that's very good. You are right. 7 minus 5.85 plus um so plus 0.5. And that is where the 1.65 is coming from. Thank you. Thank you very much. So it's 1.65 squared. Okay, so that is for the first one. So that's for the first one, actually. Then we have, um, let's look at the second area. So let's look at the second area. So that one too is going to be b h cube over 12. But this time around, the b is 1. And then the h is the height, which is actually 7. So it's going to be 1 times 7 cubed divided by 12, which is the centroid plus the area. And the area is also 1 times 7, or 7 times 1. Now, who can tell us the d squared? Who can tell us d squared for the second area? Who can tell us the d squared? This distance here, who can tell us from here to here? So let me give you a hint. Let me give you a hint. The whole of this figure, the centroid is what? 1/2 of 7.5. So actually the centroidal distance here for this figure, this distance from here to here about the y-axis, is going to be 3.5. So who can tell us from here to here is 5.85, and then all the way from the origin to where the centroidal x-axis is 3.5. So who can tell us the parallel axis theorem, the distance for the second area? Who can tell us? Okay, so it's actually 2.35. That's very good. So you just subtract. Okay, all right. So any questions, please? Any questions, please? Okay. So what will be the answer? So the answer is going to be um 10 times 1 cube divided by 12 plus 10 times 1, which is the same as 10 anyways. Then what you do is that 1.65 squared. Okay, so basically this is ISS for the first one, and for the second one it's going to 1 times 7 cubed and then you divide by, sorry, you don't divide again. Yeah, you divide for the second one, sorry. 12 plus 1 times 7, 2.35 squared. So basically you have 95.29, let's say 95.3. So 95.3 centimeters to the power 4. Let's do the same thing for the IYY. So this is IXS. Let's do the same thing for the IYY. So for the IYY, it's going to be what? So please pay attention here. Whenever you do the S bar and then you are coming to do the um the Y bar, sorry, whenever you do the ISS and you are coming to do the IYY, okay, all what you have to do is to just switch. Okay, are you okay? All right, all right. So it's going to be just swap for the Y axis. That's all. So this time around will be 1 times 10 cube divided by 12. But who can tell us? I want someone to help us with this. Please look at the question carefully. If you draw a Y axis, which is a centroidal Y axis, it will pass through exactly where the Y axis is. Okay, which means that the Y axis is passing through the centroid exactly. So if I ask you, what is the parallel axis distance? So what is the parallel axis distance between this reference Y axis and then the centroidal Y axis of the areas? What do you see? You can see that the Y axis passes through exactly on the same axis. Look at it carefully. So what do you see? So clearly we can say that it's 0. That's all. And then um for this one too, of course, it's basically, yes, it's 0. Thank you. And then we look at the other one. Um so 7 times 1 cube divided by 12 plus 0. So 1 times 10 cubed, okay, divided by 12 plus um 7 times 1 cubed divided by 12. So you have 83.92 centimeters to the power 4. So we have ISS, and then we have IYY. Any questions, please? Any questions, please? Sometimes instead of getting a T cross section, you can get an I cross section, but uh the approach is the same. Okay, the approach is the same. Um, with this small time left, I decided to spend 2 hours with you today. So with this small time left, I want to quickly introduce axial loading. I want to quickly introduce axial loading. Okay, let's look at axial loading for this small time left. Let's quickly go through axial loading. Are you ready for that? Are you ready for axial loading? Let me know. Or should we end for today? Um, we have like roughly 30 minutes. I want to also do axial loading, and then I'll teach you how to find the elongation in a member. Okay. Screw and wedges is not in um screw and wedges is not in strength of materials. It's actually in basic mechanics. So please, if you have a question on basic mechanics, you can send it to me direct. I will look at it for you. So should we look at axial loading? So type let's do it for me to know. Type let's do it, and then I will quickly pass through it with you. Type let's do it and let's see. Okay. So that's my contact there. You can reach out to me if you have any challenge. All right. So okay. So let's do axial loading, and then okay. So when it is exactly 9 p.m., then we end. Okay. Or sorry, when it's 10 p.m., then we stop. Thank you. So in axial loading, there are certain formulas which you have to look at. Okay. I will take one question, and then I'll go through the question with you. Okay. Let me take one question from your material, and then let's go through together. So essentially, okay. Okay. So all right. Please, I'm doing axial loading. Okay, I'm doing axial loading for you. Okay. So when we say axial loading, there are some important formulas which you have to look at. Okay. Whenever you have a member, so I want to teach you the concept of axial loading. Whenever you have a member, okay, and then the member is subjected to an axial load, there is some form of elongation and some stress So number one, the first equation which you have to know is that stress is given by load over area. Okay, so stress is given by load over area, and that area is actually the cross sectional area. Okay, now we also know that stress is given by the Young's modulus and then the strain. Okay, so this is another formula you have to know. And then there's a formula which is called strain. Okay, so strain is change in length over the original length. So this is as another formula. And then we have a formula which goes like change in length is load times the length A over E. Okay, so essentially that is all what you have to know. The rest is just the calculation. We have what we call the Poisson ratio. So Poisson is saying that uh Poisson is saying that, let's say I give you something like this. Okay, whenever I have something like this, imagine applying a force here. There will be a change in length along the length, and then with respect to, as the length changes, the diameter also try to shrink in. Okay, so the diameter will try to, so this is what I'm trying to say. So whenever you have a member like this, there will be change in length in this direction along the length, but then the diameter will also shrink. Okay, so Poisson is saying that we have what we call latitude um latitudinal strain divided by longitudinal strain. Now what is the longitudinal strain? So the longitudinal strain is this strain, which is what? The change in length divided by the original length. That is the longitudinal. And the latitudinal is along the diameter. Okay, along the diameter. All right, let's take one example, and then I will quickly look at how to um okay, let's take one example. So let's look at this example. Okay, so over here there's an example. There's an example here. Let's solve this example together. So what can you see? You can see that so okay, so maybe let me draw it again. So let's say you have something like this. Okay, this is P. So a circular brass of 12 millimeter diameter. So that is like the um this like the the diameter. So D is 12 millimeters and it is under tension. So that is it. Now watch this. If the increase in the gauge length of 100 millimeters, so the gauge length is 100 millimeters, and then it is what? 0.12 millimeters, right? So the gauge length simply means the test length, the one that we have used. So this is the 100 mm, and then the diameter is what we have there. Okay, the increase in length. When we say the increase in length, it means the change in length was 0.12 millimeters. Okay, so now we are to determine the stress which is developed in the bar. Is that right? Okay, so for this question, um since it is brass, we need to have the Young's modulus for brass. Now the Young's modulus for brass is somewhere around so the Young's modulus of brass is somewhere 200 times 10 to the power 3 megapascal. That is the Young's modulus of brass, or sometimes 200 gigapascal. Okay, so how can you find the stress? It's simple, very, very, very simple. So stress is Young's modulus times strain. Okay, but what is strain? Strain is change in length over the original length, right? So I can say that stress is Young's modulus multiplied by change in length over the original length. So very simple and straightforward. The stress developed will be 200 times 10 to the power 3 multiplied by the change in length, which is 0.12. Then I will divide the whole of this by the length, which is 100. That's all. Any question up to this point? So the stress is simply 200 multiplied by 10 to the power 3. Then you multiply this by 0.12 divided by 100. And what's that? So the stress is going to be 240 megapascal. So that's the stress. The stress is simply 240 megapascals. Um, sorry, I think the Young's modulus for brass is 102. The 200 is for I think aluminum. I'm sorry. It's supposed to be 102. For brass, it's around 100 or 102. Yeah. So it's actually 102. So the answer is 122.4. 122.4. Okay. And then it says, what is the change in its diameter? So what is the change in diameter? Now to calculate the change in diameter, we have to look at what we call the Poisson ratio. Okay. So we have to know the Poisson ratio for brass. Now the Poisson ratio for brass is actually 0.32. But this one, it will be given to you in exams, or I mean from the question. Poisson ratio is 0.32 for brass. Okay, so essentially, the Poisson ratio is going to be the latitudinal strain divided by the longitudinal strain. Okay, all right. So first of all, let's calculate the latitudinal strain. It's going to be Poisson ratio multiplied by longitudinal strain. Okay, now um so the longitudinal strain is going to be the change in length over the original length. So it means that Poisson ratio is 0.32. Then you multiply by the longitudinal strain, which is more or less like the change in length over the original length, which is 0.12 divided by 100. Okay, now when you solve for this, you will get 0.32 multiplied by 0.12 divided by what? 100. And what is that? 3.84 times 10. So 3.84 times 10 minus 4. But what is the latitudinal strain? So the latitudinal strain is the change in diameter divided by the original diameter. Okay, which means that the change in diameter, so the change in diameter will be the latitudinal strain multiplied by the diameter, or the original diameter. Please, if you have not liked the video yet, kindly like the video. And if you have not subscribed yet, kindly subscribe. Thank you. um so the change in diameter will be 3.84 times 10 minus 4. Then you multiply this by the original diameter, which is what? So the original diameter from the question was what? 12 millimeters. So you multiply by 12. Therefore, the change in length becomes, the change in diameter becomes 3.84 times 10 minus 4 multiplied by 12. So this is the change in diameter, 4.608 times 10 minus 3 millimeters. Any question, please? Any question up to this point? Any question up to this point? Okay. Now let me teach you something quickly, and then we can go. Okay. So I want to do this with you. Uh the picture is not really clear, but okay, let me try and see if I can get. Okay. So we just have some few minutes left. I want to use it to solve some simple question with you. Um, I have already solved this question on my channel, but I quickly want to solve it with you. So let's look at this question and then we end for today. Okay. So sometimes you may be given something like this. Sometimes you may be given something like this. Where you have a structure like this, and you've been asked to find the internal forces, okay, and then maybe find the stress, okay. So this is how you are going to do it. Okay. So for this question, is let me go straight forward. There is a support here, so there will be support reaction. Okay, there's a support there, so there will be support reaction. So that support reaction will be in this form. Let's say R. So first of all, you have to sum forces along the x, positive to be 0. And I know that I did basic mechanics with you guys, so you know how to sum forces. So R minus 75 plus 100 minus 50 is equal to 0. Okay, so we are looking at summation of forces. All right. So what then will be R? So R will be minus 75 plus 100 minus 50. So R will be minus 25. I'm sorry. R will be 25 because I will bring it here. Kilonewton. So over here we have 25 kilonewtons for the R. Now, if you want to find the force in this member AB, if you want to find the force in this member AB, all what you have to do is to cut this member. Okay, you have to cut this member here. Okay, if you cut this member here, this is what you are going to get. You will get something like this, and then here will be 25 kilonewton. Okay, so simply put, for this member to be in equilibrium, we need to apply a force here, which is FAB, and it's actually going to be 25 kilonewton. That's all. Okay, that's all. And then if you want to find the force in this member BC, you will cut here. Okay, when you cut this place over there, um okay, maybe let me do it here. So if you cut that portion, you will have something like this. So there is a 25 kilonewton coming. Then you have something like this up to this point here, and then you see something like this. Don't forget that there is a force of so there is a force which is coming here already. and that force is 75 kilonewtons. Okay, so you ask yourself, so I have 25. Let's look at summation of forces on this body. So if you look at summation of forces on this body, it will be 25 minus 75, which is minus 50. So it means that if I want this body to be in equilibrium, I have to bring a force which will counter it. So minus 50 will be like a force which may be going to the left, okay, the net force. So all what we have to do is to bring a force here, which is going to be FBC, and that force will be 50 kilonewtons actually. Essentially, it is this 50 kilonewtons, okay. All right. So essentially, you just have to um so we are done for FBC. So if you want to do CD, you stand here and cut. Now if you cut, you have, so either you look at the whole of this or just this simple portion here. Now if you look at the simple portion, you have something like this. You have a 50 kilonewton coming this way. Simply put, if this body should be in equilibrium, then FCD should come here. FCD should come here. And then 50 kilonewtons. That's simple. All right. So in effect, the force in member AB, which is FAB, is going to the negative direction. So it will be minus 25 kilonewton. So the force in member AB is minus 25. But then the force in member BC is going to the positive direction. So FBC will be 50 kilonewton. Okay. And then finally, FCD is coming. So if you look at FCD, it's also in the positive direction. So FCD is what? 50 kilonewton. That's all. Now, if you have been asked to find the stress, all what you will do is to find the force over the area. Okay, so if you know each of the areas, you can find the force in there and then the areas over there. Okay, and then if you were asked to find the total deflection, it will be the deflection in area 1 plus the deflection in area 2 plus the deflection in area 3, which will be FAB multiplied by LAB divided by the area AB, and then the Young's modulus of AB. Okay, then plus the force in BC, the length in BC divided by the area BC, Young's modulus of BC. And then the third one is the force in BC, the length in BC divided by area in BC multiplied by E, which is the Young's modulus of BC. Okay, but for this question, we have solved the force and everything. But when you were given the length and then the area, then you can calculate both the stress in each bar, and then also you can calculate the deflection in each bar. So thank you very much for joining today. That's my contact. You can reach out to me if you have any question. Uh, Thank you very much. Have a nice day, or good night. It's already night. So good night, guys. Cheers to you all. Bye.